So test 4 is on Thursday, the week you get back. And that's chapter 4, chapter 11, chapter 12, the first half, which is brain. Second half is spinal cord. That'll be on test 5. Any questions? So just a little preview.
Are we continuing brain today, or are we just?
We're doing both brain and chapter 4. We have to. We have to keep up with it. If somebody has trouble speaking, maybe they cannot speak, then they have aphasia, total aphasia, actually, global aphasia, I think we call it. If you just have difficulty with speaking, then you have some kind of aphasia. Okay, we're going to look at that in the brain a little bit today. Okay, so I had it up, I'm putting it back in.
Is that supposed to be caused by damage in that area below?
It could be probably different things, but especially if you have damage in one area, it makes a difference. We'll talk about some examples. You don't care about kids.
No, girl, literally, I saw the A in the beginning of it. Oh my goodness. Oh my goodness. Okay, hold on.
I wondered what it was. We're actually going to go to chapter 4 first. Chapter 4.
I'm hearing him better.
So we've done chapter 1, 2, 3, and now we've also done 5, 6, 7, 8. So 4 is one we kind of left behind there. We want to do that now. Okay. Here on page 116, the pages may not be the same. Somebody said they weren't exactly the same. But here we have page 116 in my book, and this is really interesting. I mean, look at that. Somebody took a body's form and stuck in what's inside, which you normally don't see that. You see people with clothes on, but you don't see, even if they don't have their clothes on, it doesn't look like that. So this gives you an idea of where organs are in the body. So then remember, how many basic tissues did we have? How many categories? 4. Can you name them? Nervous tissue, connective tissue, I always put the two together, connective tissue, muscle tissue, and epithelium. And you can say just plain epithelium, or you can say epithelial tissue. Okay, so those are your 4 basic tissues. How many do you need to have an organ? 2. 2. Most organs have all 4, but if you have 2 of them, you got an organ. Does the aorta have 2? Does the aorta have 2? Now that's our question. Does it have a lining inside?
Yes.
Okay, then that's epithelium. Does it have muscle in the wall?
Yes.
Well, then that's an organ. So actually, aorta is an organ. You don't usually think of that. You think of heart, you can think of stomach, but you don't think of the aorta as being an organ. But it qualified. And it's got nervous tissue in it too, so it well qualified. So we've got these 4 basic tissues, and we want to look at them. So here's the brain. What does it fit under? Nervous, the spinal cord. Nervous, the nerves. What part of the nervous system nerves are? What nerves are what part of the nervous system? What? No. Peripheral nervous system. Central has no nerves. So brain and spinal cord, there are no nerves. Get that down. There are no nerves in brain and spinal cord. What's a nerve?
A bundle of axons.
Very good. A bundle of axons in the PNS. So if you're talking brain and spinal cord, that's CNS, there are no nerves there. So if you have bundles of axons in the CNS, what's it called? What are they called?
Neuron.
No, bundles of neurons, bundles of axons. Tracks,
Ah.
that's right. What was your first track?
Hypophysical.
Try it around, turn around. Hypothalamic, hypophyseal tract. Where'd it go?
Between the thalamus and the hypothesis.
No, from the hypothalamus to the posterior pituitary. That's where your hypothesis is, but if we just say it easily, we would say pituitary, posterior pituitary. What does it carry there? Oxytocin and
antidiuretic.
ADH, antidiuretic hormone. So a little review there for the chapter 16 endocrine system. If we're finishing week 10, then we got 11, 12, 13, 14, 15, and that's it. So time is going quickly, very quickly. And week 15, you'll have your final exam. You'll also have test 5. So you're having test 4, then test 5, then the final exam.
And the final is comprehensive?
It's comprehensive, yes.
So cumulative of everything?
Anything could be on there. Believe me, I got enough stuff that could be on
Is
there.
it gonna be 100 questions or more?
It's probably gonna be 50,
Oh, okay.
so each one counts more.
Oh. Scared of you.
All right. It's planned to be open book, open note.
The final?
It really shouldn't, it shouldn't.
No.
No, it should.
We're getting an honest opinion here. No, it should be.
It's a lot of information.
Yeah, it's a lot, but you've got to store it in your upstairs, up here. Because you're supposed to know when you walk out. You've had all kinds of benefit. You've got cell phones, computers, notes, books, you've got all kinds of stuff to help you along. And extra credit points even. Oh, my word. So we can see all these different tissues here, and that's nice. Over here, what are we seeing? Cilia. They're usually along an edge. Okay, what happened to these poor things?
They got slices.
They got slides, making a slide. So they're thin here. This one's a scanning electron microscope. Look how nice that is. I mean, that's nice.
It looks like a seal.
Yeah, it does look like the anemones in the sea. The thing about it is, electron microscope doesn't usually give you color, because it's electrons, it's not photons, it's not light.
So it's just black and white.
So it's black and white. I think they probably enhanced it somehow. But I don't know. That's the way it looks here.
There's no way to like have a functional electron microscopy.
You mean one that you just turn the dials and watch it, look at it?
Like live, yeah, it's always
Yeah.
a photograph. Right?
I don't know. I honestly don't know. Okay? They're doing amazing things now, so I can't say no. It used to be, no.
I know it kills whatever they take a
Yeah.
picture.
So I'm not sure if it killed those cilia or not. They were beautiful. That was nicely done. So now we saw that person with the body parts, and now we're going to go to page 140. I'm going clear to nearly the end of chapter 4. Okay? We want to move through this. So when I look at that, what I see is a field of dandelions with somebody flying kites. That's what I see. Okay? That's not what the book expected. So what are these kites?
Neuron.
Neuron cell bodies, and then they each have one axon. And when it sends a signal, it goes down to the boutons, it doesn't go the other way. So they act like they're royalty, and what do the kings and queens all have? Lots of servants. So here are the servants. Who are they? Neuroglia. What's the ratio? 10 to 1. Okay, so your neuroglia are out here to help the neurons, and that's what we've got on here. What they call them? They call them nuclei of supporting cells. So kind of dropped the ball there. That's what they wanted you to know. Cell body of a neuron is what these things are. Each is the cell body of a neuron with the nucleus. What would you see coming out of here if you could see it? Dendrites. Yeah, those are probably thin and not showing up there like they did when we drilled. Okay. So why did we look at this? Nervous tissue. So now that we saw nervous tissue, where do we go next?
Muscle tissue?
Muscle tissue. This is page 139. I'm going backwards. Just seems nice. Okay. So down here, where are we? In the abdomen, we got the stomach, we got the large intestine, small intestine. And what kind of muscle are we looking at? Smooth. Is it voluntary or involuntary? Involuntary. Is it striated or non-striated? Non-striated. That means it doesn't have
Sarcomeres.
sarcomeres, right? So these cells are pretty small, tapered at both ends, and stuck into a sheet. And each one has one nucleus. So that's what we look at. Okay? In the wall of the stomach, in the wall of the intestines, to contract. That's what they do. We go up above and we see, what are we looking at? The heart. What kind of muscle? Cardiac muscle. Only in the heart. Okay? And we know the cells, when they come together, will have an intercalated disc. And you can see them there. That's pretty nice. And they have nuclei, usually one or two at the most. And does this look compressed? Does it look tight? It's not tight like this, is it?
No.
Okay, why isn't it so tight? Because it has spaces. Now the question is, why does it have spaces?
For blood?
No, not really. Here they show you, the cells are branched. So you can't pack them together like you could down here, okay? Okay, so let's go over to the next page, which is 138. And we see loads of stripes or striations and really long cells that they had to cut off both ends because they're so long. What is this? Skeletal muscle, and it's multi-nucleated. And what are the stripes? Dark, A-band, light, I-band, and that's how you get it. And that's because of the sarcomeres, okay? And what's in the middle of the light I-band? H-zone, no, that's
Z-disc?
Z-disc,
Oh, the right out there.
okay? And Z, the shining Z is one sarcomere. Okay, basic contractile unit of skeletal muscle.
So in that photo there, is it like,
This one?
yes, is that, so is one sarcomere one white band to one white band?
Yes, so it's little here.
Yeah.
Okay, but just sarcomere to sarcomere to sarcomere one, that's a lot. From end to end sarcomeres, what is that? It's in a muscle cell.
Myofibril?
Myofibril. And if one of the sarcomeres contracts, they all do. And if one drinking straw contracts, all of them do, and the cell contracts.
And they contract at different rates?
Well, I'm not sure about that. You do have, this is voluntary muscle, so you have control over this. So you can make it so your contraction is not like that. You can do stuff like that, so I'm not sure everything and how it totally works, how quick it is and all. Smooth muscle is not fast, but it's powerful. Smooth muscle is just as strong as skeletal muscle. Slower, but just as strong, and it's very efficient. It doesn't take nearly the energy to contract smooth muscle. That's kind of neat. What do you have up here in the corner? Blood, okay. And what, most of the cells here are what? Red blood cells, are their name technical name?
Erythrocytes.
Erythrocytes. What are they lacking? Nucleus, that's the only mature cell in the body that has no nucleus, is an erythrocyte. These have, what are they? Tell me it better. Lymphocytes, no? Right. Leukocytes. White blood cells are leukocytes, but one of them here is a lymphocyte leukocyte, and it's mostly nucleus, isn't it? This one has nuclei, parts. It has a nucleus, but it's a little bigger. This is the most common white blood cell. What's the most common white blood cell? Neutrophil. Neutrophil. And then the next most common? Lymphocyte. Okay, next most common? Monocyte, which can change into macrophage. They change into macrophages. Then you have eosinophils, then you have basophils. So the memory device is never let monkeys eat bananas. And that's pretty hard to do. If you got a banana around, that monkey's not going to make your life very pleasant. Okay. Never let them eat bananas. Basophils. Okay. So does this look like something that's connecting things? No. But you know what they call it? Connective tissue. And you say, why'd they do that? Well, they had to put it someplace. And they said, this is good as anything, they threw it in there. It's not really qualifying by connecting stuff, it isn't. But what it comes from is the same thing connective tissue comes from, so they decided to include it.
From like a developmental standpoint?
Uh-huh.
So blood is considered connective tissue?
Yes, strangely, it is. Okay. Now we're looking down here, and if you tell me you don't know what that is, I'm gonna wonder about you. What is it? Oh, that's the easy way.
Compact.
Compact bone, because these are osteons. And you won't have osteons unless you have compact bone, and you have trabeculae if you have spongy bone, but they don't right here. Up here, these little cells are actually chondrocytes, a line of chondrocytes, and these are collagen fibers. So it's like a layer cake. You got collagen fibers running across, and you got cells, and you got collagen fibers, cells. It's like a layer cake. And these are chondrocytes. So this must be cartilage. Which kind? It's not hyaline. It doesn't look like hyaline, does it? Fibrocartilage. That's right. Where do you have fibrocartilage? What color was it in the book? You first learned about it.
Green.
No?
Annulus fibrosis.
It was what color? That was part of it too, but. What was the red one? Yeah, in the front, the red one. Pubic symphysis, and that was fibrocartilage. And remember the discs in the spine? They were red too. The center of a disc is nucleus pulposus, but the ring around is annulus fibrosis, and it's fibrocartilage. So they had that as red. What were the other red spots? No, that wasn't red.
Wasn't it one of the knee?
That's right, 2 in the knee, 2 in each knee. What were those? Menisci,
Yeah.
right, they were fibrocartilage. If somebody tears a cartilage in the knee, that's probably what they tore.
Yeah, meniscus.
A meniscus, right. Because the hyaline cartilage in there is stronger. It's not so likely to get torn. It could get damaged, but it's less likely. Those menisci are just, you can crunch them and damage them. Okay, so that was good. So what kind of cartilage was that? Fibrocartilage. Now we're coming over here. Here are chondrocytes, and they look black in here. See this black stuff? That's simply because they decided to stain these fibers. So which fibers are they? Elastic fibers. So we're looking at elastic